Welcome to The Explainer. Today, we're talking about a huge shift in the world of AI. It turns out the next big leap isn't just happening in massive, faraway data centers, but right here, in your car, on the factory floor, and maybe even in the palm of your hand. We tend to think of the cloud as this all-powerful, infinitely fast thing. But for a lot of our most critical technologies, even a tiny split-second delay in processing, what engineers call latency, can make all the difference in the world. Think about these situations for a second. A self-driving car can't afford to wait for a signal from the cloud to figure out how to brake in a blizzard. Paramedics need a specialist to see a patient's vital signs right now, not a few seconds from now. In these moments, making a decision instantly isn't just a nice-to-have, it is absolutely essential. Okay, so here's our game plan for this explainer. First, we're going to dig into why the cloud has this speed problem. Then we'll get into the solution, Edge AI. We'll see it in action in the real world, talk about the roadblocks to getting it deployed, and finally, we'll peek under the hood at the incredible hardware that makes it all possible. So the big problem with doing everything in the cloud is that delay is just built into the system. Your data has to take this long road trip from your device, across the internet to a server, get processed, and then a decision has to travel all the way back. And that round trip, well, it takes time. So just how big is this speed gap really? Well, check this out. A huge study found something pretty startling. Less than a third of us can actually get that super fast, under 10 millisecond response time from the cloud. And that's the kind of speed you need for things to feel truly instantaneous. And this chart just illustrates the solution so perfectly. The moment you move the computing power closer to what we call edge servers, that number literally doubles. All of a sudden, almost 60% of users can get that critical low latency performance. This performance gap is exactly what Edge AI was designed to fix. So, what this is all about is a really fundamental shift in where the thinking actually gets done. And that, right there, is the core idea of Edge AI. It's actually a pretty simple concept. Instead of sending all your raw data on that long trip to a distant data center, Edge AI does the heavy lifting, the computations, the decision-making, right there, locally, on or very near the device itself. Here's a great way to think about it. The cloud is like a giant central library. To get an answer, you have to travel all the way there, find the right book, and travel all the way back. The edge, on the other hand, is like having that exact book you need sitting right on the bookshelf in your room. Access is immediate. Okay, so the idea makes sense, but where is this actually happening right now? Let's take a look at how Edge AI is already shaking things up in some huge industries. Let's start with digital health, a field where every single second can make a difference. Edge AI is creating a totally new standard for patient care, both in the ambulance and in the hospital. This means that paramedics can now live stream patient data and get real-time advice from a doctor before they even pull up to the ER. Inside the hospital, patient data can be processed right there on site for maximum privacy and instant alerts to the nursing staff. And for remote care, a wearable can detect if someone falls and call for help on the spot with zero cloud delay. And this quote from a report by STL Partners really hits the nail on the head. This isn't about making small, tiny improvements. This is about saving crucial time when it matters most, turning a dangerous delay into a potentially life-saving action. Now, for things like self-driving cars and drones, Edge AI isn't just a feature, it's pretty much the only way they can navigate the real world safely and reliably. By processing all that sensor data right on the vehicle itself, an autonomous car can react instantly to a person stepping into the road, even if its cameras are being blasted by rain or snow. Real-world data shows this local processing can slash decision time by up to 40% and boost accuracy by 25% in those exact tough conditions. And it doesn't stop there. Edge AI is also completely changing our factory floors and personalizing how we shop in ways we're just starting to see. This is the tech that lets a factory spot a tiny defect on an assembly line in real time, preventing waste down the line. It lets a huge piece of equipment predict when it's about to break, saving a fortune in downtime. And it's the magic behind everything from personalized ads in stores to smarter security systems in our homes. Okay, but let's be real. Taking these incredibly powerful, complex AI models from the cushy, resource-rich world of the cloud and stuffing them onto tiny, power-sipping devices, well, that comes with some major challenges. It's not as simple as just flipping a switch. Here's the heart of the problem. A model that works perfectly in a lab with endless computing power and perfect data often falls apart in the real world.
An edge device has to get by with a fraction of the power and memory, all while trying to make sense of messy, unpredictable data 24/7. It's a whole different ballgame.
So engineers are basically juggling a ton of things at once. They have to figure out how to get one AI model to work on hundreds of different pieces of hardware. They've got to shrink these massive models down to size, and they have to plug this new tech into old systems, all while making sure a network of thousands of devices is secure from attack. No small feat. But of course, for every big engineering challenge, there's a new wave of innovation. And in this case, the solution is coming from an amazing new generation of specialized, custom-built AI chips. And this is definitely not a one-size-fits-all situation. You've got absolute powerhouses like the NVIDIA Jetson, which can deliver a mind-boggling 275 trillion operations per second for high-end robots. That TOS number is basically just a measure of raw AI brainpower. But then you have these super efficient little guys, like the Halo 8, packing 26 TOPS into something smaller than a coin for smart cameras. And you've got a whole range of other chips from companies like Qualcomm, Google, and Rockchip, each one built for a specific job, from drones to smart speakers. So at the end of the day, it's pretty clear that Edge AI isn't here to kill the cloud. Not at all. It's creating a powerful partnership. The cloud is still the best place for training these giant models and storing huge amounts of data. But the edge is where the action is happening, where that instant, real-world speed is a must. And this combination, pairing that immense power with incredible speed, well, that leaves us with a real question. What amazing new realities are we about to unlock?